Okay, this is section 2.7, and we're talking about solving ration equations and mixture problems. If every once in a while a formula comes along that's really, really handy, I'm going to teach you one today. It's a formula for mixture problems, and it's really important. Okay, here we go. Here is not a formula for mixture problems. We're going to start with the stuff we learned yesterday and make sure you're good at it. If I want to clear this fraction out of here, in fact, there's two fractions. I could multiply by 3. That would fix one little part of it. I could multiply by 7. That'd fix a different part. What would be even smarter to multiply by? 7 times 3, which is 21. Multiply by 21 on each part. Why is that so smart? Because when I go like this, 21 times this, 21 times that, and 21 times that, both this and this are going to get canceled. Do you see what I'm saying? All right. I'd like you to write this problem down, multiply by 21 in each part, and see what you get. This is called algebraic manipulation. You have lots of things, lots of numbers, lots of variables. The problems take up a lot of room. There's a lot of little parts, and one of them I realized that to write down the problem correctly with the thing you multiply by on everything, you have 85 characters to write. 85. I counted them. The point is, the test that's coming on this has lots and lots of little parts. You have to practice it or you will not be good at it. The test that's coming is not happening until mid-January. It's our last test of this quarter and the last of the semester, other than the final. Okay, and it's algebra manipulation, and it's going to be hard, I'm warning you. Not saying it can't be done, but if the problem takes 85 characters to write down, along with the first step of actually solving it, that's a lot of stuff to write. All right. You should have this written down by now. Some of you are being slackers. I don't want to call your names, but I expect you to be writing with me. All right. So I'm multiplying by 21 on each spot. Watch what happens. 7 goes into 7 once. 7 goes into 21 3 times. I'm just doing a little canceling there. 3 goes into 3 once. 3 goes into 21 7 times. So it ends up being 3a plus 7 times 1, which is 7, equals 21 times 2 is 42. Doesn't that green equation look a lot easier? Like something you would have solved in 7th grade? Yeah, it's like really easy now. Subtract 7 from both sides, divide by 3, you'd have the answer. Do you get what I'm saying? All right. I want you to try another one like that. A over 9 plus a over 3 equals 4. Multiply by something smart. Solve it. Okay, if you multiply by 9, here, and here, and here, what's my new, oopsie, I put the parentheses around the wrong thing, but it'll still work. A plus what? 3 goes in here once, 3 goes in here 3. 3 times A equals 9 times 4. So 4A equals 36. This is going to be easy. Do you see what I'm saying? All right, that's an important thing. That's called clearing the fractions. All right, so when it's like this, you still got to transfer what I just taught you to this. Now we can't multiply by x, that won't fix it. We can't multiply by x plus 2, that won't fix it. What could we multiply by? X times x plus 2. That'll fix it. Multiply that and each part right now. Needs to go there. And it needs to go there. Got one on each part. It's a lot to write, I know. Stuff cancels. Cancel, cancel. 5x plus cancel, cancel. 3x plus 6. Multiply that out. 2x squared plus 4x. Do you see how this is going to be a quadratic? All right, I'm going to get all this stuff together and call it 8x plus 6 equals 2x squared plus 4x. Now I got x's on both sides. I got to get them all to one side and set it equal to 0, because that's what you do with quadratics. I'm going to get that over there by subtracting 8x from both sides. And I'll have 6 equals 2x squared minus 4x. Now I'll have 6 over there, and I'll have 0 equals 2x squared minus 4x minus 6. How do you solve quadratics? Factor it. What else? Calculator and graph it. What else? Quadratic formula. Good. Okay, so I'm going to factor this one. Oh, 2 comes out first, by the way. That'll make it way easier. You should finish it. Tell me what the answers are. Come on paper. You've got them on paper? Okay. Did you seriously want to come check that? Okay. 0 equals... No, really, I didn't want to record. Anyways, okay, I'm back now. And I factored this thing down to x, and then what does it factor to? Plus 1 and minus 3. Okay. And so then final, I better double check that. Outside and inside makes negative 2x. Good. Okay, final answer, x equals negative 1, x equals 3. I got 2 answers. Now, here's a really important thing. I mentioned yesterday. Does anybody remember that I'm not done? What should I do to finish? Yes? Check, because what is common in these kinds of problems? Extraneous answers. Negative 1 and 3 are the 2 things I should check. If I put in a negative 1, does it cause any problem on the bottom there? Does it cause any problem on the bottom there? If I put in a 3, does it cause a problem there? Cause a problem there? So I didn't have any extraneous answers. But I'm telling you, when you least expect it, expect it. All right, there's another one. This one, we would not multiply by x minus 5. We would not multiply by x minus 2. We would multiply by x minus 5 times x minus 2. This is one where, I think this is the one where I wrote down and it takes 85 characters to write out the problem. So I'm not going to make you do that, just to save us time. But I am going to write it myself, x minus 5, x minus 2, and then I'm going to do the clone thing. Infinite clone, and I'm going to multiply it here and here, and then I want you to look at that, cancel what can be canceled in your head. That'll save you a ton of strokes on your writing, and then write down the equation you have left once things have canceled. For instance, that cancels that. Now we have this times this. Write that down once you've multiplied it in your head. Three x times the x, 3x squared. 3x times the negative 2, negative 6x. That cancels that. X plus 5, or x minus 5, sorry. And that's a positive. It's a plus right there. So a plus. Does it need a parentheses? No. There's nothing to do in the parentheses. Nothing's being multiplied by my parentheses, so just drop the parentheses. Okay, then this whole thing cancels all of this, and the answer is just 2. Raise your hand if you had that. Good. Okay. So then, how do I finish it? I just have to put it all onto one side and set it equal to 0. So I'm going to say 3x squared, and then the x's go together, and I get minus 5x's. And then I'm going to put this over to the other side, makes it a negative 2, and a negative 5 makes negative 7. And then this can be solved with factoring, or with graphing, or with quadratic formula. And let's say that one of the answers came out to be 2, and the other answer came out to be negative 8. What should I check for? Extraneous. And would one of these have failed? Yes, this one would fail. Because as soon as I put the 2 in right here, oops, it has a 0 on the bottom. So it doesn't work. Might look like it worked, but it's an extraneous. All right. One other thing in your homework is they're going to give you a graph, and they're going to say, these are the two answers you got. Which of them actually works? Well, remember, if these are solutions, they're also zeros, they're also roots. What's the other? There's 4 things we call these. Solutions, zeros, roots, and what else? X-intercepts. So by saying these are solutions, they're not saying that it's a line at x equals 3. They're saying that the solutions, the roots, the zeros, the x-intercepts are these. Is one of these right? Or are neither one of them right? Or are both of them right? All right. X equals 3. Do you get that x equals 3 would be right there? Is there actually a root there? No. So that gets thrown out. That's extraneous. Is there a solution at x equals -3? -3 would be right there. Does it seem to be touching right there? Yes, so that one works. This one works. That one's extraneous. That's problems 19, 20, 21, and 22 in your book pair, just like that. And at first I looked at them and was a little confused, because I was thinking that those were lines, and what they really are is roots, or zeros, or x-intercepts. So I just have to see what's really an x-intercept and what's not. All right, I'm hearing angelic noises. Have I gone to heaven, or is it somebody's cell phone ringing? Okay, we'll just not talk about it. Just hopefully it doesn't ring again, or we'll have to hunt them down. All right, so here is that big, awesome formula. You need to write it down. You won't remember it. It's going to be tested. You will have to know this. And it works for a lot of problems. It's like one more tool you can grab when you're in the middle of solving problems from now on for the rest of your life. At some point you'll probably forget the quadratic formula if you stop using it, but right now it's pretty well ingrained in your head. Get this one ingrained in your head for at least the next 3-4 years. You bet you anything you'll see it on the SAT test or the ACT test. There'll be some kind of a mixture problem. They're really common. I remember seeing it in calculus. I remember, and you're going to see this, well, you're in pre-calculus and you're seeing it now. So it's pre-calc, you're going to see it in calc, and I bet you'll see it on the SAT or the ACT. All right. How much pure acid must be added to 100 milliliters of 25% acid to get a mixture that is 85% acid? Let's make sure you get what I'm talking about here. You got one vial that's pure acid. Yeah. We'll make it black, like it's like really dense acid, although acid is usually like clear, I suppose. But all right, and then this other acid is kind of weak. It's 25% acid. So that's like, here's a vial with that kind of acid in it. It doesn't say, oh, I have 100 milliliters of the one. I don't know how much of this. This one, I don't know how much it is. But this one's 100 milliliters. So I've got this green acid, which is like a little weaker acid. I'm going to pour really strong acid in there until the mixture gets to be 85%. Do you get that if I add really strong acid, it's going to increase its average percent mixture? Does that make sense to you? If it starts out kind of weak, you pour in pure acid, it's going to get stronger and stronger and stronger. At some point, it'll 85%. All right. So here's how the formula goes. Amount 1% 1 plus amount 2 times percent 2 equals amount 1 plus amount 2 times total percent. And the first thing you would do on a problem like this is you would write the formula. You would write the original formula, like that one. You'd write that down. And then you'd stick the numbers into it. Okay? I would just do it in the order they give them to you. This gives me this part. How much pure acid? That's this part. Now it says how much. That implies they're not telling you how much, right? So what do I put if I don't know what it is? X. The amount here is X. What percent acid is it? 100%. Plus, here's the next part. 100 milliliters of 25% acid. That goes in here. I'm putting the blue with the blue. And the amount, 100 milliliters. Times the percent. What percent do I put there? 25%. Equals. This is the total. I'll do that in green. 85% acid is all they tell me. They don't tell me how much that we have. They just tell me it's 85% acid. So that goes into this under total percent. Goes right here. And amount 1 and amount 2 I can figure out from what I had before. The total percent is 85%. And now what's amount 1? Amount 1 was right here. Amount 1 was X. So I put X. What was amount 2? Amount 2 was right here. It was 100. Now, when I clean this up, you're going to see an equation emerge that is a nice, simple equation that you just have to solve. Your title of your next test is called Algebraic Manipulation. That means you're going to have big, honking equations that you have to solve. Okay, so this is going to be it's not even that bad. 100% is the same as 1, right? So 1 times X is just X. Plus 100% times 25 is 0.25, right? 0.25 times 100 is 25. Equals. And this part, 85% is the same as 0.85, right? So I'm going to take 0.85 times X is 0.85X. And the 0.85 times the 100 is 85. Do you get how the green equation right here is just a simple equation that you solved in like 7th grade? It's just a simple equation. You just have to solve it now and you'd have your answer. What would your answer be? Your answer is a number of milliliters that I'm going to add of pure acid. If my answer comes out to be 10,000 milliliters of acid, I might be thinking, okay, that's something's off. Double check and make sure it makes sense to you. All right, so next thing. To get these alone, I have variables on both sides. I get rid of the smaller one, minus 0.85x. Draw the line. Then I have 1x minus 0.85x is 0.15x plus 25 equals 85. And then I subtract 25 from both sides, 0.15x equals 60. And then I divide by 0.15 on both sides. X equals, is it like 300 or 400 or something like that? Somebody take 60 divided by 0.15. Thank you. You got a calculator on your desk. Take a second. 60 divided by 0.15. Got an answer? Okay, what's your question?
Why is it 85 not 0.85?
This one and this one canceled out. They're gone.
No.
Why is this 85 right there?
Yeah, no.
Okay, because we put 0.85 times 100 gave me 85. All right, and it was 0.85 times the x gave me 0.85x. So it's right. Thank you for checking. I do make plenty of mistakes. Okay, so did you divide 60 divided by 0.15? 400. Thank you. And does that make sense in the context of the problem? Do you think if you added 400 milliliters, that's a fair amount of pure acid, to this weak acid, that it would end up being 85% acid? Does that make sense to you? Yeah, that seems reasonable to me. Not, you know, you could be off a little bit, but at least it's not way, way off. So 400 seems like a reasonable answer. There we go. So it's 400 milliliters. All right. If you understood that, you should be able to handle this one. Same exact thing. Start by writing the formula. Stick the numbers into the formula. If you've already got the formula written, stick the numbers in it now. It even helps by saying X milliliters of pure acid, 125 of 60% acid, total is 83% acid. There's your 3 parts. All right, true to what I told you, I'm going to write this formula. Amount 1, percent 1, plus amount 2 times percent 2 equals amount 1 plus amount 2 times total percent. I would start writing the general formula. Really, honestly. That's how I'd start the problem at home on a test. Do you have to? No, as long as you have the numbers perfect. The next step is what you have to write, but I strongly recommend you start with the formula. All right. So on this, amount 1 is, I don't know, X. Percent 1 is pure acid, 100%. Plus amount 2 is 125. 60% acid equals amount 1, X, plus amount 2, 125, times total percent's 83%. Now, the next step, I'd probably do a little simplifying. 100% is 1, 1 times X is X, plus, I don't know what 125 times 0.6 is. Can somebody help me out with that? Thank you. Equals. And now I'd have to multiply this out. 0.83 times X is 0.83X. And this times this, and this times this. And can somebody help me out with 125 times 0.83? Thank you. And now I just have to solve for X. From there, you can handle this. If you can't handle this, you're in deep trouble on this test, because this is very easy from here on out. Because these are hard algebra problems. There's lots of complexity to them. All right? When you're all done, what should you do? You should check it and make sure it makes sense. So if you get an answer of like 0.1 milliliters, that's like a drop of pure acid, and you said, wait a minute, is a drop of pure acid going to be enough to change 60% acid to 83% acid? That's not enough. You should realize your answers must be wrong, and then you go back and fix it. So make sure your answer makes sense. Okay, by now you should have already solved it. What did you get? Anybody get the same? Awesome. Thank you. Now I look at that problem and I say to myself, okay, if I'm adding pure acid and I want it to add to 60% acid, it's going to go between 60 and 100 pretty quick. It's going to get up to 60, 70, 80, and that makes sense. Yeah, that makes sense to me. That seems reasonable. If you're only off a little bit, it'd be hard to tell. But if you're way off, you'd at least be able to catch yourself. All right. Good. You have learned everything that you need to know for tonight's homework. Tonight's homework is, in my classes, might be different on different teachers, but right now I'm saying page 253, problems 31, and that's an application question about mixtures, and then 13 through 27 odds. Tomorrow will be even more application based. We'll do a lot of application stuff. And then the next day will be just kind of a review day and much more light. Hopefully just have some fun. Some people are talking about bringing in some food.